When we're faced with three brackets like this, it does present a bit of a problem. Sometimes we get thrown off of what we can do here. But consider if I had 2 times 3 times 4. Now this is a problem we get in primary school. We can't really times all these together at the same time. If we had eggs and boxes, 2 lots of 3, that's okay, but we can't really draw down the third dimension coming out of the page. That's just, we can't really do that on paper. But we can approach these individually. We can do 2 times 3, that gives us 6, and then times that by 4, that's going to give us 24. It doesn't really matter what order we do these in. We could do 3 times 4, that gives you 12. Times that by 2, that gives you 24. 2 times 4, that gives you 8, times that by 3. So I'm going to follow a similar method here. I'm just going to expand these brackets out 2 at a time, rather than trying to tackle all 3 at a time. Not only it's possible to do all 3 at a time, I could just consider that x is going to be times by each of these and just try to figure out a way of doing it, but it just gets a bit messy doing it that way. So expanding out the first one, I have x times x to begin with, that's x squared, and I have x times 2, that's 2x, then 1 times x, just to be lazy I'm just going to add that on and simplify as we go, but of course when you're writing this out you might have to do another line of working out to simplify this down, and then 1 times 2, that gives you 2. And now we're going to expand that against x plus 3. X squared times by x cubed, x squared times by 3, that's 3x squared. Now 3x times x, that's another 3x squared. So again, I'm just going to simplify that as I go. That gives me 6x squared. Then we have 9x, adding another 2x, so that's 11x. And then 2 times 3, that gives us 6. Now we can't go any simpler than this, and we're in the form we're looking for. These are all integers. We effectively have a 1 before there. So this is looking good. This is in the form we want it. We've probably done this correctly.